Good afternoon, everyone. Am I audible to you?
Yes, ma'am.
Okay, so welcome to the first live session of the course Kinematics of Mechanisms and Machines. So, I think people are still joining. So, yeah, and it's the first class, so we can maybe wait for 5 more minutes and then we can start. So, meanwhile, I'll give my introduction and you all also can introduce yourself. So, my name is Malik Arslan Nisar, and I am currently in my second year of PhD at IIT Kanpur. So, basically, I have done my bachelor's in mechanical engineering from NIT Srinagar, and after that, I have joined for PhD here in IIT Kanpur in the Department of Mechanical Engineering, and my specialization is in robotics and automation. So, maybe you all can introduce yourself one by one and basically why you are taking this course and what you expect to learn from this course. So you can maybe start with your introduction. Anyone voluntarily? Otherwise, I'll call names. Okay, so let's go in the alphabetical order. So Arjun, you may unmute yourself and maybe you can turn on your camera also and just introduce yourself. A brief introduction, like.
First, my name is Jagdish Sai Kumar.
Okay, so you're from, like, tell me your college name, the college or course you're doing, you're pursuing, and the purpose of taking this course.
My name is Jagdish Sai Kumar. I'm studying in mechanical engineering second year, KL University, Vijayawada.
Okay,
Mechanical engineering is to uh, design. I am a design engineer in future.
okay, okay,
Some
that's good. And so, who's next? Isha. Isha, can you hear me?
Yes, ma'am.
Ha. So, can you introduce yourself?
I'm Kodali Isha from Cade University. I'm studying mechanical engineering.
Okay, in which year you are?
I'm in second year.
Okay, and Hariam.
Hi, hello, ma'am. Good afternoon,
Good afternoon.
and good afternoon all. And my name is K. Ram, and I'm I from Chennai. So I'm currently studying in B Mechanical from St. Peter's, Avadi. So why I choose this course because this is a part of engineering, kinematics mechanics. So that's why I learned this course.
Okay, so next is, I don't know how to pronounce it. Dilip Kumar Nara Haris. Uh, Dilip, how to say your name?
Yes, ma'am. It's Dilip Kumar Nahar Sethi. Dilip Kumar, just fine. Good afternoon, ma'am.
Okay, good afternoon.
I am from mechanical engineering. I'm studying mechanical engineering from KL University, Vijayawada, of
Mm-hmm.
second year.
Okay, so I think a lot of you are from the same university, right?
Yes, ma'am.
Okay, so do you have any
Actually,
option there? Haha.
in second year, we have kinematics and dynamics of machines, KDOM as subject. Our sir has said that we can join that NPTEL course for your further understandings, better understandings.
Okay, okay, that is good. Then who's next? Pakala? Is it Pakala? I'm sorry if I'm pronouncing your names incorrectly, but Can you hear me?
Yes, ma'am. Myself, P. Balaji, and I'm from KL University. Right now, I'm doing mechanical engineering second year,
Mm-hmm.
even sir. Um, yes, ma'am. There's having in kinematics and dynamics. Right now, we are studying the subject to understand the links and some other basic topics about the kinematics and dynamics.
Okay.
That's
Um,
it.
Next, Rajiv.
Good afternoon, ma'am. My name is Rajat Kumar. I am working as assistant professor in Department of Mechanical Engineering from the Foundations, NASIC.
Okay.
We joined this course to learn better learn the understanding, better understanding of the kinematics of machines.
Okay. Okay. And next is Ramalinga. Who is it? Ramalinga ji?
Good afternoon, ma'am.
Yes, good afternoon.
My name is G. Ramlinga, ma'am.
Mm-hmm.
I am studying second year BTech Mechanical Engineering in KL University.
Okay, so same.
Okay.
Okay, then we have Surya. Surya, are you here? Surya, can you hear us?
Yes, ma'am.
Yeah, kindly introduce yourself.
This is Surya from second year BTech Mechanical Engineering from Saint Peter College, Audi.
Okay,
Oh, kinematics. My sir referred this subject for NPTEL course.
okay, okay. So you have this course in your college also, or you're just taking it from NIPTEL?
Yes, ma'am.
Okay, okay, okay.
No, they are referring from college itself.
Okay. um, Let me share my screen first, then maybe we can start. So, have you all gone through the weekly lectures that have been uploaded?
Yes, ma'am.
Okay. So, how many lectures? I guess five have been uploaded till now, right? Yeah. So, let me give me a minute. Let me minimize this. Okay. So, I guess most of you are from like BTech only, and maybe some one or two people have joined the course, out of interest or something. So, sorry, here there is a mistake here. It should be kinematics of mechanisms and machines. I'll take care of it. So, can anyone summarize what all you have gone throughout the week, the content? Anyone? Okay, let's go in the sequential manner. You see here like three words: kinematics, mechanisms, and machines. So, can someone explain like what a mechanism is? Anyone? No one wants to say? What do we refer by a mechanism? You must have studied during the week. Okay, so sorry. Okay. So basically, mechanism is a combination of rigid bodies, okay, which are connected in such a manner that when they move, they have a relative motion in between. Okay. Any combination of one or more, sorry, not one, any combination of two or more rigid links which are connected in such a manner that there is a relative motion at any time between the links. So that is what we mean by a mechanism. Okay. So for example, um, yeah. So for example, we have a hinge to which we have connected a link. Okay. And then here another maybe hinge or any sort of a rotating joint, and then we have another link. So you see that whenever this is a fixed link, right? This is ground, so we call it a fixed link. So this is a fixed link, this is another link, and there is a hinge in between. And what happens is that we try to move this link in this direction. Say for example, we give it a theta angle, we rotate it by a theta angle. So here you can see here you can see that there is a relative motion between this fixed link because it's fixed, and this is going continuously in a motion, okay, as we give it a as we rotate it with an angle theta. So there is a relative motion between the two links. So something like this is called a mechanism. It has links and it has basically joints. We say kinematic pairs or joints. Okay. Now, after mechanism, we learn what a machine is. Okay, so this is just a summary of what you have already gone through. Whenever you are joining a live session, you are expected to go through the week's lectures so that you can understand better and you can easily solve the problems. Okay. Now, coming to the machine, that what is the difference between machine and a mechanism? Machine is nothing but a collection of mechanisms, okay, which transmit force from source to the load or resistance. What does this line mean? It means that there we have a link from where we input some energy or a force, then it transmits that energy to the subsequent links, or maybe wherever we want the output of that link. So the force is transmitted, and such kind of collection of mechanisms or a mechanism where this force is transmitted or the energy is transmitted is known as a machine. Okay. Now basically and thus performs mechanical work. So we know that if the force is transmitted and there is motion, so definitely there will be some work also. Okay. Now what do we mean by kinematics? Kinematics you all have been studying from class 11th or 12th, right? So can anyone tell me what kinematics is? It is like obvious from the definition also, but what is your understanding of the kinematics? Can anyone tell? Uh,
It is the study of the motion of body and the system without considering their side physical properties and the force acting on them.
okay, not physical properties, but yeah, force you can say. For example, if we are studying in kinematics, we study the motion of the particles and we consider basically their velocities only, okay, which you will further do in velocity analysis and everything. That time the force causing those velocities, okay, that we do not bother about. Okay, we just deal with how the velocities relate to each other. Okay. So basically in this like course also you're going to study about that how there are like how different mechanisms are formed, how motion is transmitted in different kinds of mechanisms, how velocity changes, or how velocity propagates from one link to another link. Okay. So basically that is how you deal with the kinematics part. So maybe I'm not sure in this course if we have the dynamics portion also. There you can maybe study about the forces also. So this is basically what we are going to learn in this course. Now, briefly revising about the nomenclature, what do you mean by a link? So, link is a rigid body. You all know what a rigid body is? Can anyone tell me what a rigid body is? You see this term here, like? Can anyone tell what we mean by a rigid body? No one? If you won't say, I will take names and then I'll ask. Okay, so Narendra, I think you'll join late also. Can you tell what a rigid body is? Are you here? Okay, Arjun, maybe you can.
Physical body. Rigid, rigid body is a physical mechanism.
Uh, you cannot say rigid body is a mechanism. Mechanism is a combination of rigid bodies, right? Yeah, Balaji.
Actually, it is a solid object which doesn't deforms under external forces, something like that, maybe.
Rigid body which doesn't deform under external forces. Yeah,
Or it
partly.
doesn't changes in its shape
Yeah,
or applying any forces.
yeah, partly it is correct. Okay. So, the proper definition of a rigid body is basically that if we consider a body and in that body we consider any 2 points, okay, say point A, say point B. This point can be located anywhere. I have chosen them arbitrarily. So, what is the definition? It is that the distance between these two rigid bodies does not change with time. Okay, the position between these two rigid bodies does not change with time. So, there is not a relative motion between the parts of a rigid body. Say, for example, uh, like if we, as you have must have studied through the week, that given a mechanism, how do we differentiate between two links? How would we say that this is one link and this is another link? Basically, when there are two links, we know that every part of this link, if we give a motion here, if we give a motion here, this will move as a complete body. Okay, there won't be relative velocity between the parts of this body. Okay, so basically that is what a rigid body means, that the position between 2 points does not change with time. However, if there are two links, the relative position between these two links can change. So that is how we classify whether it is a single link or these are two links or these are three links. We basically look at the motion of the links. Okay, understood? So now, what is a link? A rigid body moving relative to other links. So within a link, there is no relative motion. Okay, it will have one motion only. There is no relative motion between the parts of a link. And when there is a different link, there will be a relative motion. Okay, so that is the what is written here. The rigid body moves relatives to other links in a kinematic chain. Now, this link has several types. We can have a singular link, we can have a binary link, or we can have a ternary link. Singular link means that this link is basically connecting to just another link. Okay, I said that links in a mechanism, mechanism is nothing but a connection of links, sorry, a combination of links. So in a combination, maybe one link can connect to another link, or maybe two links can connect to a particular link. Okay, so that is how we classify the links. A singular link connects to just one link. A binary link is one which connects to both, like two links. A ternary link connects to three links. Okay, that is how we classify different links, and it goes so on, quaternary link and so on. So I'm like just summarizing all this. It's expected that you must already be knowing about these things, so I'm just giving a brief summary. I'll not explain in detail. So after that, we have kinematic chain. Okay. Now, kinematic chain is a combination of interconnected links. Okay. It can be closed, open, or hybrid. Can someone tell me what a closed kinematic chain is, and what an open kinematic chain is, and what a hybrid kinematic chain is? Anyone?
It does not consist of singular link. No singular link.
Okay, which one is that is closed, right? So basically, the closed kinematic chain means it does not contain a singular link. That means all links are connected to either two or more links. For example, yeah. For example, we have this kinematic chain. Okay, it is a four bar mechanism. So here you can see that this link has two connections. One, it is connected to this link, and other, it is connected to this link. Similarly, this link also is connected to two links. This link also is connected to two links. So here we don't have any singular link. It can be classified as a closed kinematic chain. Now, open kinematic chain is one in which, okay, you tell me what is open kinematic chain.
Open kinematic chain is it is a consist of at least one singular link. There is no closed link.
Okay, yeah. So there is at least one singular link that is called an open kinematic chain. Okay. So maybe you can see if I can write this.
At least two binary singular links is required for open chain.
Yeah, you can say like that also. For example, here, wait a minute. I'm not. Okay, anyways, for example, this is a open kinematic chain. Okay, if we hinge this here, for example, you must have seen a two link manipulator or a robotic arm. Okay, these are basically singular kinematic chains, because we have certain end effector at the at the these last link of the mechanism. For example, here you can see we can have an end effector here. So this is an open kinematic chain. Now, a hybrid kinematic chain is one in which there can be closed as well as open kinematic chains. So you can see these in many devices also, that we have, suppose, a closed kinematic chain like this. Then here we have added another link, so like this, two other links. So this, you can say, a hybrid mechanism or hybrid chain. Now, it also has two types. Okay, so we can have planar kinematic chain and spatial kinematic chain. So anyone can tell the difference between the two?
2D links is said to be a planar mechanism, and a special mechanism is the 3D objects. 3D links are connected, then it's said to be a special mechanism.
So you cannot say 3D links are connected, like materials or any object will be 3D only, but it is the about the motion. If
Yes, ma'am. Yes,
Yeah,
ma'am.
if
More than if motions occur in more than one plane, then it is a special link. And if motions take place in a single plane, then it's the planar link.
yeah, so if there is the link motion is between parallel planes. Okay, it's not necessarily only one plane, and there can be other parallel planes. If all the links of a mechanism move in parallel planes or a single plane, we call that a planar mechanism. uh, and if the motion is in more planes, like perpendicular planes, we call that a special mechanism. So the basically the motion is in 3D. Now, what is a kinematic pair? So kinematic pair is nothing but what we call in simple terms as a joint. Any connection between two links. Now this connection can be a hinge, this connection can be a pin, or this connection can be say a prismatic joint, right? So basically we call these as kinematic pair. Example R and P. So R is what? R stands for what? Revolute joint, and P for prismatic joint. So this is, yeah. So revolute joint will have, okay, let me come to that first. So the kinematic pair is described or quantified by a pair variable, right? As I said that it is a connection between two links, and we know that there is a relative motion between two links. So what kind of motion it is, that can be quantified or described by like the kinematic pair, and we have a pair variable for that. For example, as I said that a kinematic pair, for example R, which is a revolute pair, so basically a hinge, there the pair variable can be theta, right? Because at any time if you see a mechanism like this is fixed, then we have a link like this. Now at any like if we are continuously, and let me say that it is a yeah, basically this is a hinge, so it is a planar mechanism. So I can move this link from like this 0 degree to say for example 90 degree, okay? So we can specify its position with this theta. So this theta is a pair variable. So for the hinge we can say that the kinematic pair variable is R, okay? And the kinematic pair between this fixed link or the ground and this link is what? R, okay? And similarly in prismatic, what do we have the pair variable as? Anyone? What is the pair variable in a prismatic joint? Nobody knows?
Translation.
Yeah,
Translation.
translation is, so yeah, we can say S. So basically translation is the pair variable. Now kinematic pairs are classified as lower pair or higher pair. In lower pair, as you know, it is a connection, okay? I am repeating again that kinematic pair is a connection between two links. So if this connection is with the help of area, like there is area contact between the two links, then we call it as a lower pair. And if there is point or line contact between the two links, we call it as a higher pair. Now coming to degrees of freedom. So my screen is not moving, right? Oh, okay, now it's there. So can you tell me what is meant by the degrees of freedom? Like what do you understand? The definition is already there, but what do you understand? Anyone? Anyone can say, maybe Hey Ram, you can say.
Hello, audible ma'am?
Yes.
I think for the degree of freedom is any kind of body that movement linked in joint. So I think this
I'm
is
not
the
able to hear
degree of
you. I think
freedom.
there is some noise. Can you speak a bit louder and clearer? Like try to speak.
Any kind of body that movement of freedom, that is called degree of freedom, in use for any kind of mechanism like.
No, I don't think that is the correct definition. Anyone else wants to try what a degree of freedom is? You must have studied this in the week's lecture, right? How many of you have gone through the week's lectures? Can you raise your hands? Those who have watched all the 5 lectures or whatsoever has been uploaded. Because if we do questions after this, you won't be able to do it if you have not gone through the lectures or if you have not studied these. Can anyone else try to say what a degree of freedom is?
Hello, ma'am.
Yeah.
Ma'am, actually, one unique kind of you will take one object. The
Actually,
object
I'm
moves
not
in
basically
3 degrees of freedom.
able to hear you properly. That is why there is issue. It's fine if you know it. That's fine. If anyone else also knows, he can like tell. Okay. So basically, degree of freedom is the as the definition says, it is the minimum number of independent coordinates that need to be specified to fix the configuration of a mechanism. What does that mean? Let's take a simple example in 2D, right? We have 2D here. Now we know that suppose there is a point, it will have an x coordinate and a y coordinate. If we want to locate a point on a plane, right? We want to know its x coordinate and y coordinate, right? But suppose we have as I said that the in context of mechanisms and the mechanisms and machines, the number of independent coordinates that we need to specify for the configuration of a mechanism. For example, I take this example of a hinge. We have a fixed link and it is connected to one more link. Now, to decide about this position or the configuration of this mechanism in this plane, at any moment of time also, we would want x and y, right? But here, this term is important. It is the minimum number of independent coordinates. Now, these are known as spatial coordinates, right? These are Cartesian coordinates or spatial coordinates. But we also know that we can describe a theta here, okay? And then we can relate these x and y basis on this theta, because here x will be, suppose this is L, so x at any time will be L cos theta and y at any time will be L sine theta. So ultimately it's only theta that is required to know the position of this end effector of this link, okay? At any time we can write x is equal to L cos theta and y is equal to L sine theta. So ultimately there is only one variable or one independent coordinate that needs to be specified. So we would say that the degree of freedom of this link or this mechanism here shown is 1. Okay, that is theta. So that is the degree of freedom. Now for the calculation of degree of freedom, generally in 3D, we say that every body or any object has 6 degrees of freedom, right? It can go in X, Y, like positive, negative, okay, and Y and Z. So there are basically 6 degrees of freedom in the spatial kind, if there is a spatial kinematic chain. But if there is a planar mechanism, there we say in plane any body has a 3 degrees of freedom. Now this formula which I have written here, it is to calculate the degrees of freedom of a spatial kinematic chain. If it were a planar kinematic chain, this 6 will turn into 3nl minus 1 minus 3nj and plus summation of fii running from 1 to number of joints or kinematic pairs. So this is basically uh, like I mentioned that any link in the this planar will have at least 3 degrees of freedom. So if we have one link, it will have 3 degrees of freedom. So that is why we multiply with 3. Now why this 1 comes? Minus 1, you must have studied this in the lecture. That's why I will not elaborate it. It's basically if there is a fixed link in the mechanism. So obviously that is completely immobilized, right? We take away its all degrees of freedom, because if we fix it, then it has no degree of freedom, it cannot move. That's why we minus those threes. And this is basically a formula we have arrived, so that if we know the number of, because in a complex mechanism you may not always be able to see from the eyes like directly that yeah, this will have this many number of degrees of freedom or it can move like this, because sometimes we there are complex mechanisms like 3 bar 4 bar, like there may be many links. So for that, this formula has been designed so that you are able to calculate the number of degrees of freedom that the mechanism has ultimately. Here, let me go to the next page. Okay, it's not here. So here this NL represents the number of links in the mechanism. Okay, NJ represents the number of joints or kinematic pairs, like there can be a revolute joint, there can be a prismatic joint, or other sorts of joints like cylindrical joint. For cylindrical joint, you know the degree of freedom is 2. So similarly, this means the number of joints, and this Fi basically is the degree of freedom of that joint. Okay, so that is how we calculate the degrees of freedom of any uh, like mechanism. So if anyone has a doubt here, you can ask me now, because after that we'll do questions and there you would be requiring like the knowledge of this thing. So is it clear, or anyone has any doubt? Okay, I guess it's clear. So should I move forward?
Yes, ma'am.
Okay, sorry. Now, these are some key points that a mechanism has at least one degree of freedom. So, in order to classify any combination of links, that whether it is a mechanism or not, you have to check that whether it has at least one degree of freedom or not. Now, if it does not have that one degree of freedom, also it has 0 degree of freedom, we call it a structure. Okay. So because we are mechanical engineers, we mostly deal with mechanisms. If you look at civil engineers, they have to usually deal with structures, like right, trusses and etc. So those combinations have 0 degree of freedom. Now, an over constrained structure has a negative DOF. So while calculating the degree of freedom of any mechanisms, you will see not mechanism, obviously that is a structure. You can see that sometimes you arrive from that formula, you arrive at negative degree of freedom. So what does that negative degree of freedom means? It means that the mechanism was already constrained. Okay, it had already sufficient number of constraints, but still we had added any other link or something like that, an extra link which was not even required. So that turns its degrees of freedom into negative. So that is a basically over constrained structure. Now a mechanism with exactly 1 degree of freedom is known as a constrained mechanism. Okay, and a mechanism with more than 1 degree of freedom is a robotic mechanism. Okay, understood till here? Now moving forward. Okay, I think my screen is stuck. Okay. So basically that is all, and now maybe we can, yeah, so maybe we can start to do questions. Okay, is my screen visible?
Yes, ma'am.
Yes, ma'am.
Okay, so now you all can give this question a try and tell me what answer you're getting. First you will try, after that we will discuss it.
Ma'am, this degree of freedom is option D one.
Option D. No, I guess that's not correct.
Option C,
Option
ma'am.
one.
Okay, option C. How many of you are getting option C?
Number of links is 2,
Option
joints
C,
is
ma'am.
2, and
Yeah,
Fi is 2.
yeah. So you can put your answers in the chat box because you are turning your mics simultaneously. It creates noise. Or maybe you can say one by one. Okay. Yeah. So Rajiv, you're saying something. Yeah. Okay. You are also getting C. So C is the correct option. So can anyone explain how did you get that?
Yes, ma'am. In this case, number of links is 2, and joints is 2, and Fi is 2. That's why we got this answer.
Yeah. So see, as I said that it is firstly you have to identify it is a planar mechanism, right? Now here we know that the formula for calculation of the degrees of freedom is 3 into NL minus the number of whatever it is fixed links. Okay, let me call it NLF. Okay, and then it's minus 3 into number of joints, and then plus summation of degree of freedom of each joint. Okay, so I running from 1 to whatever it is j. So here what is the number of links first? You can count that here we only have two links. This is one link and this is the another link. Okay, so we say the number of links is 2. After that we count number of from these NL, it is 2 and NLF is the fixed link, so it will be 1. Okay, it will be 1 here. Now number of joints, you can see there is one hinge here and another hinge here. Okay, so it is R and it is R, so this is also 2. Now again we know that degree of freedom of these revolute joints. A revolute joint has, as I mentioned, only one degree of freedom. So this will have one degree of freedom, this will have one. So this summation will turn into 1 plus 1, that is 2. So this Fi summation of I running from 1 to 2 is also equal to 2, right? Now, okay, let me do it here. It will be what? 3 into n minus 1, that is 1, then minus 3 into 2, then plus 2, right? It will be what? 5 minus 6, that is minus 1. Okay, so option C is the correct option. And what does this tell us? That this structure has been over constrained, right? Is it clear to everyone?
Yes.
Okay, so those of who you were getting the incorrect answer, I guess maybe you must have done a mistake in like counting the number of kinematic pairs or anything, or maybe it would have been a simple calculation mistake. So I guess now it would be clear. Now moving to the next part. Wait, someone is still, people are still joining. So I would appreciate it if you people join on time, okay? And also that every one of you should be with a pen and paper and like solve. Just don't sit through the lecture. Try to do it yourself. Now we have this second question. So okay, first, can you tell me how many of you have gone through the weekly assignment? Like, have you all gotten the weekly assignment already? Anyone?
Actually, this is our first class.
Oh, this is your first class.
We are from Kerala University, and sir recently told us to. Sir recently created the account through NPTEL to listen the class. So this is our first class.
Oh, okay. So have you studied these things already in your university or not? Because then it would be difficult for you to. understand these things. Have you done this portion in your college?
Yeah, ma'am.
Okay,
Basic things like kinematics and kinematics chain and basic problems on this kinematics pair, and types of motions, types of links.
okay, that is fine then. If you have done, it's fine. But
Yeah.
yeah, now I would appreciate if you, okay, you can still try the questions because you have already gone through the theory. So you all can do the questions here, and then maybe you can try the weekly assignments because this session is to help with the weekly assignments. So it is fine. Okay, okay, some people have submitted assignment one, that is also good. You can try to be punctual with these things, but you can still solve this if you have not gone through the assignment. And basically you can solve the assignment even after the live class because this is the class is just to help you to be able to solve the assignment, so it's fine. Now if anyone is, anyone
Sorry
is
for the
have,
interruption, ma'am.
sorry.
I'm sorry for the interruption. And where we can find this assignment questions, ma'am?
I guess there would be some portal. I don't have the access to the new assignments. These questions are from previous assignments, or maybe you can ask from your fellow, like, colleagues here.
Faculty members who referred this.
So you would be having a SWAM ID, right? Then you would be watching the videos from the portal, right?
Yes, ma'am.
So maybe in that portal there would be assignments also. Is it so? Deepayan, can you tell? Is it so? Okay.
Yes, ma'am. It is there on the portal. Like along with the weekly lectures, the assignments are also present.
Yeah, so that is great. You can check from there, okay? Everyone who is doing like has joined today only, you can check from the portal whether you are able to find the questions or not, okay? If not, then there would be something for queries also. You can put your query there, okay?
Okay, ma'am.
Okay. So, how many of you have gotten the answer? I can see only two people have done it till now. Not two, three. Ajay, Ram, and Arjun. Anyone else? Others are trying. So yeah, B is the correct answer. Okay, it is a relatively simple problem. Again, what we do, we have this formula. So let's start by counting the number of links. So how many links do we have here? So this is 1, right? This is 2, this is 3, this is 4, this is 5, this is 6, this is 7, and this is 8, right? So these are the links. So we have 8 links. Now the number of kinematic pairs. Okay, so see, this is 1. Okay, we can say it is R. So I'll not write R every time because here we have only the revolute joints. There is no prismatic joints. So this is 1, this is 2, this is 3, this is 4, this one's 5, 6, 7, 8, and 9. Okay, so the number of joints is, or kinematics pair is 9. Now what is the summation of the degrees of freedom of these 9 joints? Again, each of them are revolute joints, and all of you know that revolute joint has only 1 degree of freedom. So for these joints, each one will have 1 degree of freedom, though, so summation of this fi will be 9. Okay, it is basically f1, f2, f3. So the degree of freedom of each joint. So each joint has 1, so it will be 1 plus 1 plus 1 up to 9, and it will be 9. Now putting it in the formula, it is 3, n is 8, and we have only one fixed link here, so minus 1, right? And then minus 3 into number of kinematic pairs, then plus number of degree of freedom. So it will be 21 minus 27 plus 9. Okay, Is it correct? I guess I made some mistake here. There will be 10 joints, right? There will be 10
Number of joints 10, ma'am.
yeah, number of joints will be 10. Okay. uh 1 2 3. Okay, wait a second. This one is 1 2 3 4 5 6. Yeah, this one I have missed, right? So this here will be 10. So it will be 10. You can correct me when I'm doing wrong. Okay, so this will be 10, and again, uh, with the same logic, this will also be 10. So this is this is the formula, okay, for degree of freedom. Now it will be 30 plus 10, so it will be minus 9 plus 10. So the degree of freedom for this mechanism is 1. Now just by looking at the mechanism, you wouldn't be able to say how many degrees of freedom it has. There are so many joints and so many links, so this formula comes handy. Anyone has any doubt here? Okay, if not, then maybe we can go to the next question and you can try this one. Oh, okay, you don't have to calculate the number of degree of freedom. It is the similar joint here. Now you have to say how many ternary links are present in the kinematic chain.
2, ma'am.
Okay, 2. So ternary is basically which has connections to 3 links. So you can look at this link. Okay, here it is connected to this link. One, it is connected to this link, and then it is connected to this link. So it is a ternary link. So this one is a ternary link. Now look at this one also. It is also connected to this link, then to this link, and then this link. Sorry, not this link, to this link. So these are the 3 links for this one. So this is also a ternary ring. So the answer here will be 2. Now coming to the next question. Find the degree of freedom for this mechanism. You can take your time to like copy it. So 3 minutes, 3-4 minutes, then we can discuss.
And this is 2 degree of freedom, right?
2. Let me check the answer. I guess it is 3. No, wait a minute. No, it's a 1 degree of freedom system. You must have made any mistake. So anyone got 1? connection. Sorry, I think I lost my connection. Is my screen visible now? Anyone got the answer? Okay, 4. Wait a minute. Is it 4 minus 1? That is 3, right? Ajay, can you tell me how you got it?
Madam, one madam answer. That is fourth question.
Oh, okay, okay. Fourth one, yeah. No, the 1 is not the answer. It is 3.
Okay.
Yeah, it is 3. Okay, so maybe if you guys are making a similar mistake, let's do this together. Wait a minute. Full screen. Yeah. Okay. So see, first we start with calculating the number of links. So what is the number of links here? Tell me. What is the number of links? You can unmute yourself and tell me, like, I want to see where you are making the mistake. So the number of links is what? Okay, see. Now,
Man, 9.
no, it's not 9, it's 10. Maybe you're not counting one of the links. So see,
Oh yes, it is 10. I missed the this sliding pair over here below.
yeah. So see, fixed link is always counted as one only, okay? Because ultimately we say that the fixed link is the ground, so fixed link is counted as one link only. So this link, this fixed link here, 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 it is one link. It is a ternary link because it is connected to 4 links, like this link, this link, this link, and this link. So it is a ternary link, but it is one single link, okay? Don't count it as 4. So this is one link. Now this is the second link, okay? This is the third link. This is the fourth link. Now this here is a ternary link. It is a fifth link. This is the sixth link, okay? Then here it will be seventh link. Then this sliding pair here, it will be eighth link. This link will be ninth link, okay? And this here will be 10th link, okay? Clear till here? So the number of links will be 10. After the number of links, those who have not watched the lectures, you might find it a little difficult because in different some colleges they use the, I think there is Bird's criteria or something like that. I'm not remembering the name right now. So the formula is slightly different for calculating the degree of freedom. But if you go through the lectures, this will be clear, okay? I would appreciate, like, I will encourage you to go and watch the lectures and then try the assignment. You will be able to do it if you're not able to do it right now. So the number of links here we have calculated as 10. Now next is the number of joints or number of kinematic pairs, okay? So whenever you're looking for number of kinematic pairs, just check where is the relative motion between the links, okay? So that is the kinematic pair. Now see here, this is the fixed link and this is the first link, okay? Sorry, the second link. This is the fixed link, then this is the second link, and here we have one revolute pair. Okay, so this will be one kinematic pair. Now look here. Here it's not just a prismatic pair. This here it can rotate with the help of this link, and this can slide also. So here it is one R and one P. So here we have two kinematic pairs. Correct? Now here this is one R. Okay, this is one rotating pair, this is another rotating pair, and this is another rotating pair. Okay, here also this can rotate, so it is R. Now coming here, see here we have one P because it can slide, so it is a prismatic pair here. But then here is this is R, but you will count 2R here. Why? Because this link can have a relative motion with respect to this link, so that will be 1R, and it can have a relative motion with respect to this if this link is moved some in a way. So this will be here 2R. Okay, so you will count 2R here. Coming to this one, here it can slide on the surface, so 1P, and this is the rotating. Okay, here you can see this portion, so it will be a rotating pair. So this is R. Now how many are there? Number of joints: 1 2 3 4 5 6 7 8 9 10 and 11, right? So I guess, is it 11? RP R R R R RP.
12, ma'am.
Okay, is it 11?
Ma'am, over there where you counted 2 hours, there should be 3 hours. The
Where?
slider.
Slider here?
Yes, ma'am. On the right hand side.
The right hand side. No, I think only 2 hours should be there. No, why would there be 3 hours? Yeah, here there are R and P. Here, na?
Okay, okay.
Yeah, so R and P will be there. So it is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 it is. Okay. So this is number of joints is 12. And now degree of freedom of each joint. So you know all of these are either revolute or prismatic, and everyone has a degree of freedom 1. Okay, if you go through the lectures, you will like there is sir has taught it that for revolute there is 1 degree of freedom, for prismatic there is 1 degree of freedom, for spherical there is 2, not spherical, for spherical it is 3, for cylindrical it's 2. Okay, so all this is there only, so that is why I did not repeat those things here. But now since we have uh, 12 number of joints here, and each joint has its own 1 degree of freedom which it can give, so it will be 12. Okay, now putting this into the formula, it will be 3 into 10 minus 1, the one fixed length, and then minus 3 into 12 plus 12. Okay, so it will be what? 3 into 9 is 27 minus 3. I think I made a mistake. Wait a minute. Yeah, there is something wrong. Number of joints is 12. Number of links is 10. Okay, no, it's fine. And it will be minus 3 ones are 3 plus 2. So calculate this. It will be what? It will be minus 9 plus 12. It will be 3. Okay. So yeah, this is fine. So understood? Does anyone have a doubt in this question? Because this is really important. It is the like first step for this course. If you have doubts, you can ask me now. Everyone understood? Say something, at least yes or no, or maybe.
Yes, ma'am. Yes, ma'am.
Okay, so you will get used to it with practice. Okay, and again I'm telling that first you definitely watch the lectures. Now if you have understood, then try this question on your own. there's a text here. Oh, okay, Deepayan, that's fine. Now it's good if you're in Jadavpur University also. You're in mechanical now, right? Okay, those who joined late, maybe you can introduce yourself at the end because I took the introduction of everyone who was present in the start. So please try this question, and if you're struggling or you have any doubt while solving, you can ask. That is the purpose of this session. If during solving you have any sort of doubt, you can ask me. Anyone got the answer? Are you guys solving? किसी से हुआ?
Ma'am, do you from 5?
5.
Yes, ma'am.
Strong.
Yes, ma'am. I'm also getting 5.
Okay, what is the number of links you have counted?
Number of links is 10.
Correct.
Number of
Yes,
joints
ma'am.
is 11.
11.
And
Yes,
FI
ma'am.
is 11.
Okay, number of joints you're correct counting wrong. It should be 12. Okay.
Number of
Oh,
joints.
Number of joints is 12. Okay. Let's do it together. So here. Now, wait a minute. Now first we count the number of links. So this fixed link, let me call it as 1. Okay. Now this will be the second link, right? This will be the third link. this will be the fourth link, this will be the fifth link, this will be the sixth link, this will be the seventh link, this will be the eighth link, this will be the ninth link, and this will be the 10th link, right? So most of you would have counted this correctly, right? Is it clear to everyone? Now counting the number of joints. Okay, let me erase this so that you will be able to understand, because that is something where I find you struggle. Now let's start from here. How many number of joints we will have here? At this
Three, ma'am.
One
Two revolute and one prismatic.
Correct.
one prismatic, two revolute.
Yeah, this one will be prismatic. What happened? It's writing thick. Okay, this one will be prismatic here. This one will be a revolute pair, and here another revolute pair. So here we will have two revolute pairs and one prismatic pair. Okay. Now coming to this link, what will be here? Again we will have a prismatic, and then we will have a revolute pair, right? Now coming to this one, here you can see when you like consider this link. Okay, how many revolute have you counted here?
Two revolute, ma'am.
Two. Okay, so this is also you have done correctly. So because this link, it will have a relative motion with respect to this, and it will have a relative motion with respect to this, so we will count it as R and R. Now this is again a R, and this is again R. Now how many, what will be here? How many pairs will be here? It is similar to this only, no? R, R and P. Then why are you getting number of joints incorrect?
Ma'am, here we consider only
Over here, I counted one revolute pair instead of two.
So see, this is 2 R and P, and it is similar here also. So this will be how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. Right? So the number of prismatic, not prismatic, kinematic pairs will be 12. And each of these have a single degree of freedom, right? So summation of 1 running from I to 12 will be what? It will be 12. Now putting in the formula, it will be 3 into 10 minus 1. We have a fixed link. Then minus 3 into 12 plus 12. So what is this coming out to be? I guess it's coming out to be 3 only, right? 3 into 9 minus 36 plus 12. Minus 9 plus 12 is equal to 3. Okay. So I will again say, don't make mistake while counting the number of joints. I said that joint or a kinematic pair is any the connection between any two links. So you just have to check for the relative motion. Like some of you said that you corrected. Okay, so wait a minute. I'm not getting a pointer here. Okay, wait. Okay, I don't have a pointer here. I don't know why. So let it be. Okay. So yeah. Whenever you're counting the number of kinematic pairs, just check the number of links and see how many relative motions you have there. Like for this area, you can see there are 3 links. So between 3 links, let's consider this link. It will have a relative motion with respect to this link and a relative motion with respect to this link. That is why we count 2R here. Okay, you basically have to check for the relative motions. Right, here also you can see that this this is a prismatic joint here, so it will have a relative motion with respect to the ground surface, okay, which will be a translation. Then because we have a joint also here, this joint will have a relative, because of this joint we will get a relative motion with this link, And again, because of this joint only, we will get a relative motion between this link. So here we will get three relative motions, that is r, r and p. That is how you count. Okay, so I hope now this is clear. So don't make mistakes. Now, how many ternary links are present in this kinematic chain? What is the number of ternary links in this kinematic chain? Anyone?
Ma'am, three.
Okay, three. Everyone knows three, right? But which link is that? Can you tell me?
And the two sliders and one this link.
Three. Okay. If you all are getting three, then explain how is it three? Someone was saying something about sliders. Which
Yes,
link?
yes, ma'am. The two
Ma'am, two
sliders.
ternary links is here. One is ground
One
and
by one,
another one
one
is
by
this
one.
link.
Yeah, Rajiv, you were saying something.
Ma'am, here two ternary link is here. One is ground and one is here, this point.
Which this
Uh,
one?
Actually, ma'am, I can't share my screen.
This one, right?
Ma'am, two sliders is joined. Yes, ma'am. This one.
This one.
Yes, ma'am.
No, the answer is only one. Okay.
Ternary link, ma'am. No, ma'am. Ground is also act as a ternary link.
Ground is only the ternary link here. Okay. So you can see ternary
Yes. Oh,
link.
sorry. Ternary joint. That one is ternary joint.
Yeah,
Okay,
so
ma'am.
it's not a ternary link, right? So
Yes, ma'am.
here only one link is ternary and that will be joint, because you don't have to complicate things. Just look for the basic definition. A ternary link is a link which is connected to three links. Only ground, when we count ground as only one, then it has one connection with this, one connection with this slider, and one connection with this slider. So ground is the ternary link because it is connected to three links. Okay, rest of them are either connected to one or two links.
Yes,
Okay,
ma'am.
so the answer will be one, one, and that will be ground.
Ma'am, why is a slider not a ternary link? Means it is also connected to three links. Like it is connected to the ground and two other links.
No, see, uh, you are telling this right. It is this slider is connected to this ground. Okay, that is one connection, right? And okay, you're telling this should also be a ternary link, right?
Yes, ma'am.
Then it should be four. Okay, this one, two, and three, and one, two, and three. Yeah, then the answer should be three, right?
Actually, ma'am,
Yes, ma'am.
all the sliders are act as a uh, individual component. It's not a whole components. Actually, when we consider Earth as a ground, that means we assume whole the 3 points are same point, matlab same object. That's
Yeah.
why we take as ground as a ternary link, but slider act as an individual link. It one is individual link. This one is individual. In this one individual body. But ground is the
No.
one body.
Yeah, ground is one single body, but their question is, which I also get, that this slider is one link, right? But this link is again connected to three links. No, this link, and this link, the ground and the two links. And similarly
It
with
is a
here,
joint, ma'am. Ma'am, it is a joint, not a link. Joint is another thing, and link is another thing.
But
Both are
slider
different.
is a link, right? We counted it.
you counted it as a link. Yeah, your doubt is valid. I'll check it, because maybe then I would have made a mistake. I don't have the answers for this. This question you can like keep it. I did not think about it that time, so I thought the answer would be one. I will verify it. So if maybe I am missing out on something, I will let you know. Okay.
Yes, ma'am.
Okay. So maybe then we can go to next question. So this is question number 7. Now this again you have to calculate the number of degrees of freedom. So please try this one out, okay? We have 3 hinges here. This one is a prismatic pair here, and this is a ternary ring here, and you may now do it and put your answers in chat box or whatsoever. Okay, Rajiv has calculated one. Yeah, 1 is the correct answer. Anyone else got it? Okay, 1. Everyone is getting 1 only, right? Okay. So yes, 1 is the correct answer. Those who have done, it's good. Those who have not, you can look at the solution. Okay, so again we start with counting the number of links. Okay, so here again we have ground as a fixed link. I'll call it 1. Then this is the second link, this is the third link, this will be the fourth link, this will be the fifth link. Now this link is connected to this link with the help of a prismatic pair, so it will be sixth link. Okay, so the number of links will be 6. And now number of joints. So this is a revolute joint here, so it will be R. It will also be R. This here will be R. This will be R. This will be R. This will be P, and this will be R. Right? So how many joints? 1, 2, 3, 4, 5, 6, and 7. Again, the degree of freedom of each of these joints is 1 only. So it will be, so the total degree of freedom of each of the joints will be 7. So it will be 3 into 6 minus 1 minus 3 into 7 and plus 7, right? So I guess this is coming out to be 1 only. So this is simple calculation. Now let's move to the next question. Okay, so this one is a good question, so try to solve it, like figure out the number of degrees of freedom here. And give me a moment please, I'll be back. Till then you can do it. Okay, so who has gotten the answer till now? Okay, yes, it is 1. So what about others? Okay, it is coming out to be 1. Who else is getting it? Only 2. Okay, this problem had a slightly it was slightly different from others. So Deepayan or Rajiv, would you like to explain how you got the answer as 1?
Yes, ma'am. Number of links I got 8, and number of joins I got 10.
No, I guess it is wrong. Like your answer is correct, but the approach is wrong. What about you, Rajiv?
Also consider same thing.
Huh?
Same thing. Number of link is 8 and joints is 10.
Wait a minute. Let me verify my answer then. Uh, no. How did you get the number of links as 9? Tell me that.
No, ma'am.
Ma'am,
Number of link is 8.
ma'am,
No,
8,
no, not
8,
8.
8
Yeah,
pairs.
exactly. Whatever it is. How did you get it as 8?
Ma'am,
Ma'am,
1 is ground.
Yeah, one by one. Any
Then,
one of you can say.
yes, ma'am.
Uh,
First one is the ground. First link is ground. Then in this binary link is 1.
mm-hmm,
Then this binary link is 1. Then this ternary link is 1. And here arc is 1 link.
mm-hmm,
And this shape is a 1 link.
mm-hmm.
And then this curve is 1 link. And this roller is 1 link.
See, the curve and
That's
arc, you are correct. Sorry, counting it
ma'am. First
incorrectly.
D.
This,
D is the
this, you are
D.
telling this.
Ma'am, your cursor is not visible.
Is this visible?
Yes, ma'am. This one, no, no, upper one,
This
upper
one.
one
Okay. Okay, let me
is the
number
one
it
link.
for you. So you're
Yes,
telling
ma'am.
this is one link, right?
Yes, ma'am.
This one is second link.
Hmm.
This one is third link.
Yes, ma'am.
This one is fourth link.
Yes, ma'am.
Then what?
Then this circle, that is I think it is
Fifth link.
yes, ma'am. Fifth link. Then D is the sixth link.
Uh,
Then this small strip
okay.
is one link. Yes, ma'am.
This is not a link. So
Okay,
this
ma'am.
one is a link.
This one is just a passage.
So basically, you see this here, it is a slot inside this D,
Okay, okay,
and
okay.
a pin sort of thing is moving inside it. Okay.
Okay, ma'am. Yes.
So maybe you
Then
can
set
try
another.
again. Now I have told you the links. Now
Yes,
all
ma'am.
you guys have to do is uh, count the number of kinematic pairs, and then the formula will be useful. Okay, since this is the last question, I'll give you 3-4 minutes more. You can take your time and do it. If you want more time, you can do it, because this is essentially the last problem. After that, there is a theoretical problem only, and we can end the session. So you can take 5 more minutes or whatsoever. Now you are getting the answer. So number of links we have calculated as 7. Now what is the number of joints?
9, ma'am.
9. Okay. How?
मैम यही गलत है.
Huh?
Actually, ma'am, this one is the first. One revolute total revolute joint is 1, 2, 3, 4, 5. 5 revolute joint, 6 revolute joint.
Okay. This you are calling.
And
Which is the sixth
yes,
one? Okay, here.
here, ma'am,
Okay.
6 revolute joint and one prismatic joint, one rolling joint here.
Yes, here, right.
Yes, ma'am. At
Ma'am, is
point,
rolling
link point.
mentioned in the question? Means rolling without slipping.
Rolling without slipping case.
Yes.
I don't know if it was mentioned in the original problem. Let me check. Yeah, I'm sorry I did not mention it. You can treat the rolling contact to mean rolling without slipping. Okay.
Yes,
Okay,
ma'am.
ma'am.
Sorry, I forgot to mention it. I should have done it. So here also I
Yes,
thought
ma'am.
it will be obvious, but anyways I should mention it.
Hmm.
Treat.
And ma'am, one prismatic joint is here.
Wait a minute. Without slipping. So
And two prismatic joint, ma'am.
this one is a prismatic joint. Okay. And
Yes,
what
ma'am.
about this
And
one?
here pin joint is also.
Okay. So see, let me do one thing. Let me, now you know that pin joint is a higher pair, right?
Yes, ma'am.
And
Pin
this
joint is
rolling is also a higher pair, right?
higher pair. Yes, ma'am.
So I will write it as H. Is that fine?
Yes, ma'am.
So that you people understand. Now what is the number of joints? It will be what? 1, 2, 6 are there, right? No, not 6 are. Yeah, 1, 2, 3, 4, 5, 6. Yeah, 6 are, 2 H and 1
Hmm.
P. How much it is?
अच्छा 2h that then one increase हो
9,
जाएगा
I
10 हो
guess.
जाएगा.
It's 9, right?
H, if we consider H as a single, then 9,
Yeah,
otherwise
you
10.
consider it as single because the formula we are using it, that will take care of it. I'll tell you how. So these are number of joints is 9. Okay, so everyone look carefully at the problem now. If you have not arrived at the answer, now let's go through the solution only. Then you can try at home also. So the number of joints here, or number of kinematic pairs I should say, is 9. Now calculating the number of degrees of freedom from 1 to how much? This 9. This is important here. So this R will have what? 1 degree of freedom. Then this R will have 1. This R will have 1. This R will have 1. Right? This R will have 1. Sorry, I wrote it as R. Okay, let me make it like this. Now here we have 6R. Okay, 6R. Then how many H? 2 H and 1 P. Right? Is it correct? Now 6R each has a single degree of freedom. So they will add as 1 plus 1 plus 1 up to 6. So that will be 6. After that, we have one prismatic joint. It has also a 1 degree of freedom. So it will add as 1. But we have two higher pairs. And what is the degree of freedom of this higher pair? You have to calculate. See, it has this spin here,
2 degree of
can
freedom.
this disc can rotate about this spin, and this pin can slide inside the slot, right? So it has
2 degrees of freedom.
2 degrees of freedom. What about this rolling pair here? How many degrees of freedom it will have?
1 degree of freedom.
Why 1? Can someone tell
Ma'am,
me?
only rolling like
Yeah, so here we
like
will.
if I just fix the rotation, then the translation is automatically fixed.
Yeah, so this will also have a 1. So sometimes even if you have higher pairs, you will have to calculate the number of degree of freedom. Or otherwise simply you can remember, for mostly the higher pair we have 2. So if you would consider 2 degrees of freedom here for this pin and slot, then 2 for this disk which is at the bottom. So you will write a 2 here, but after that you will have to check about the number of redundant this degrees of freedom. Okay, that is also a way that you count the number of redundant degrees of freedom. For example, see, we are mechanical engineers, we have to visualize. आप इसको ऐसे सोचो that if this disk, if I push it behind, right, if I push it behind, this disk will start rolling, right? Is it correct? It will start rolling when I push the disk. This will, the bottom disk will also start rolling about the hinge. But if I start rotating this bottom disk, okay, because it is rolling without slipping, it will not transfer the motion to this disk. Okay, the bottom one will only rotate. Okay, it will not transfer the motion. So there is where we introduce that it has one redundant degree of freedom. So we can write here plus 2, and then we subtract that redundant degree of freedom. Or we can simply, if you are able to visualize that yeah, it has only 1 degree of freedom, this higher pair here, then you can simply write 1. So it will be how much? It will be 6 plus 4, it will be 10. So in the formula also you will write it as 3 into 7 minus 3 into 9 plus 10. How much it is coming out to be?
-1 मैम छूट गया.
Minus what?
7 minus 1.
Why 3 into 7 should
Minus
be
1.
3.
3 minus 6, sorry, wait a minute. 3 into number of links
I mean,
is,
it is coming in negative now.
it is coming out to be negative.
Yes, ma'am.
Actually, minus छोड़ दिया उसने इसलिए मैम. Yes ma'am. Now it is correct.
Is
No,
it
now
correct?
it is correct.
Is it correct now?
Yes, ma'am. Yes, ma'am.
Okay. So how much is coming the answer? 1, right?
Yes, ma'am.
Okay. Yeah. So basically, this is how you solve it. So these were problems on degree of freedom. I would encourage you to solve more problems. Take a good book and then solve the problems, or even try to do the assignments. And those who have not watched the lectures, you might have found it a little bit difficult to understand. But if you go through the lectures, okay, there this process has been elaborated very simply, so you will be able to do it. Okay. Now coming to the last question, identify the kinematic linkage. What is this kinematic linkage? Can anyone tell? Don't start googling it, okay?
Ma'am, can you enlarge it? Actually, it is not visible clearly.
It's not visible. Is it visible now?
Yes.
Okay, maybe I have a weak internet, so let me zoom it. Okay. Identify the kinematic linkage. Does anyone know? This has been taught in lectures, so if you directly go there, you will be able to see it. So this is a clan linkage, okay? The clan linkage is basically a type or an example of Stephenson's chain, but since we have been given both the options, so the closer one is clan linkage, so this will be classified as a clan linkage. Okay, so basically what we have here is, in a clan linkage, there, or in a Stephenson's chain, there are two ternary links. Okay, those ternary links are connected with a binary link. Okay, the two ternary links connected with a binary link, and after that, on the other end, there are two links on one side and one link on another side. So this is basically a clans linkage. If I show it in form of a Stephenson's chain, basically we represent it like this. This is a ternary link, then we have a binary link, then we have a ternary link. Okay. And after that, these two links are connected with one link, and from here we have two binary links. So yeah, so you can see this is basically a Stephenson's chain, and in this Stephenson's chain, if we can replace this link with basically this link, so that becomes a Clance linkage. Okay. And then here this is Watt's chain. It is also another 6 bar mechanism. Basically 6 links are there, so they are 6 link mechanisms. In Watt's chain you will find it is similar only, but the difference is that here this binary link is taken from center and pushed to this other side. जहाँ पे अभी ये एक link था, here it becomes 2 links, and on the left side it remains the same. So this link when shifted to this, it becomes Watt's linkage, and if shifted to this, it becomes Stephenson's chain. So these Watt's chain and Stephenson's chain, you can these simple questions can come in any competitive exams, or maybe in your even your college exams, that what's the difference between Watt's chain and Stephenson's chain. So you can see even in lectures there are the sir has covered how many types of 4R linkages we can have, and how many types of 6R linkages 6 bar linkages we can have. Okay, so you can go through the lectures, and then like try to do the assignment by yourself. Okay, so that is it for today. If anyone has any doubts, suggestions, feedback, or like you want to include some other types of problems or anything, you can share. Or if you have any doubts or queries, you can share. Otherwise, we'll end the class.
Thank you, ma'am.
Okay. So no one has anything to say? Okay, those people who joined at last, you can introduce yourself if you want to. Like you may introduce, everyone has done. Those who have not introduced already, please introduce yourself. And I'll stop sharing my screen then. Okay. So okay, you don't want to introduce yourself, that is fine. So okay, then maybe we can meet in the next class. Okay, so I'm ending the class for everyone. Thank you so much.
Thank you, ma'am.
Ma'am, I have one doubt, ma'am.
Yeah,
Uh, regarding that first week assignment, when the due date?
I think it all should be provided in the portal. The Pine has done it, right? The Pine, when is the last date for first assignment?
This one, 5th February.
Okay, so 5th Feb. There is ample of time given for the assignment, so no need to worry about that.
Okay,
But
thank
keep
you.
checking the portal because you will get all the updates there. I mean, I do not have the direct access to the portal because the TAs there are different, and those who take the live session are different. So we don't like communicate. So it's better if you raise your queries regarding these issues in the portal itself. Okay, there would be a discussion forum, something like that, where you can put your queries, and keep checking that. Okay.
Yeah, thank you.
Okay, okay. So should I end the class now?
Madam, excuse me, ma'am.
Yeah.
I'm sorry for the interruption, ma'am. Can we get your introduction once
Sorry.
again? Can we get your introduction?
I don't understand.
Ma'am, he's
Can we
asking
get
for
your
your introduction.
introduction?
Oh, introduction.
Yes,
Okay, okay.
ma'am.
So you joined at last?
No, ma'am. After starting, after the 10 minutes
Okay,
from
maybe I
first.
would have introduced myself. So, my name is Malik Arslan Nisar, and I am currently a PhD student in the Department of Mechanical Engineering at IIT Kanpur. So, that is a brief introduction about me. I have done my bachelor's in mechanical engineering only, and my specialization is in this robotics and automation. and I am working with Professor Bishak Bhattacharya here, and that's it. And I am a PMR scholar. That is why I have to take these live sessions. So those who came late, you can also maybe introduce yourself. I see some of
Ma'am,
you.
if you don't mind, kindly can you say where in Kashmir you belong to? Like exactly which place?
Oh, I am from Kashmir. I am from basically it's close to Srinagar only. So
Okay.
yeah.
Name? My name is Shella Kumar, madam. I am from KL University.
Sorry.
My name is Shella Kumar, madam.
Okay, okay. So you're also from the same university, Kale.
I KL University, second year.
Okay, cool. And what about who is this? Narendra and Rafi. I guess you joined late, and Deepan you also. So you can maybe. Well, Deepan has given his introduction in chat. So,
Yes.
uh, in which year you are?
Madam?
Ma'am, I'm in second year.
Okay, you're also in second year.
Okay.
I'm assuming Ajay is also in second year. And what about this Narendra and Rafi? Okay, so I think they are not available. So let me end the session for today then. Okay.
Yeah, ma'am.
Okay.
It
So
was
I
really
will.
nice.
Yeah.
उसमें कल बहुत अच्छा लगा. Thank you.
Yeah. It was also nice interacting. Now we will be meeting obviously every week on Sunday. So next time I would expect you all to be prepared. Like watch all the lectures till then. Okay. Like week 1 and week 2, because today was the week 1. Since this course has 8 weeks, there will be 8 live sessions. Okay. So for every live session you must be at least have done that week's lectures. Okay.
Ma'am, to prepare for the certification exam, is doing the assignments sufficient, or do we need to refer to some books or some
Well,
additional material?
I personally don't know, but the I have taken courses before, but I don't have the idea about exams. But what students say is that the pattern is
Okay.
mostly like the assignments only. Like it will be 1 mark question, 2 mark question, and MCQ type answer,
Yes,
question answer. But
sir.
yeah, the topics or the syllabus would be the same, but obviously it won't be the same problems, right? So it's good if you
Yes, sir.
practice other from other books also. That will definitely help you in your undergrad these studies
Okay.
also, right? So it's good
Okay.
if you refer to a good book.
Yes.
Okay. Anything else? So should I end the session?
Yeah.
Okay. Okay, I'm ending the session for everyone. Okay. Thank you.
Yeah. Thank you.